Hi everyone, welcome back to our proportional relationship unit. Let's see what proportional graphs look like compared to graphs of other relationships. Today's goal is to know that the graphs of a proportional relationship lie on a straight line that go through the origin, which is at 0, 0. So let's start with this example here first. We're going to plot some points, and then we're going to notice what the graph looks like. Remember, when we're plotting points on a graph, we put them in parentheses, and then we have them in order of x, comma, y. X is always on the x-axis. That's the line that goes side to side. So we're always going to move either left or right first from the origin. Then y tells us how far up or down we have to go from that number. So if I look at my graph, I have the x-axis labeled over here. So this horizontal line here is our x-axis. That's going to be our first number. And then our second number is going to be the y-axis, which goes up and down over here on the left. So if I look at my first point, 0, 10, I'm going to start at the origin, which is 0, 0. My first number says to go to 0. That means I don't have to move right now because I'm already at 0. I don't have to go side to side. Instead, I'm going to look at the second number, the 10. That tells me how far up or down to go. If the number is positive, I go up. If the number is negative, I go down. Since it's positive, I'm going to go up 10 units, and I'm going to put a point. I'm also going to label it so that way I don't forget, or I can double check to make sure I put the point in the right spot. Then I'm going to look at the next point, 1, 8. So again, starting at the origin, I'm going to go over 1 because 1 is my x value, so that's going side to side. Positive means I'm going right. Negative means I have to go left. Since 1 is positive, I go to the right 1 place, and then I'm going to go up 8 points and put a point and label it. If we continue this, our next number is 2, 6, 3, 4, and 4, 2. Now that we've plotted all of the points, what do you notice about this graph? That's right, it looks like a straight line, right? And it's going diagonal, it looks like it's going down. Those are all good descriptions of this graph. That's going to help us to know if a graph is proportional or not proportional. Graphs of proportional relationships always have these two characteristics. Notice I said two. They have to have both characteristics in order to be proportional. The first one is the points lie on a straight line. That means all of my points have to make a straight line. And the second characteristic is that the line has to go through the origin, or the point 0, 0. Yeah. So if you look over at example 1, pause the video for a moment and decide which graphs would you say look proportional based off of these two characteristics. Do we have a straight line, and does it go through the origin? So now that you've had some time to decide which ones are proportional, let's look at this. Both A and D are proportional graphs. In order to be proportional, both of these criteria have to be met. If I look at A, these points look like they're making a straight line, but they also go through the origin. Where these two axes meet, the x-axis and the y-axis, where they meet, that's 0, 0. That's the origin. So this line is going through the origin and it's straight. If I look at B, it starts at the origin, but it's not a straight line. It has a curve or a bend to it. If we have a curve or a bend on our graph, it's not proportional. C is not proportional. It does meet our first criteria. It is a straight line, but if I look here, that is not the origin. That is not 0, 0. That's actually the point 0, 2. Okay, we want this line to go through 0, 0. And that's what D is doing. Okay, we are starting or going through the origin, and it's a continuous straight line. There are no bends or curves in it. A and D are both proportional graphs. B and C are not. So let's look at an example in our book. All we know from this table is that some t-shirts cost $8 each. We're going to use this table to answer these following questions. What does X represent in this situation? What label would we put on that column? What are we describing for X? What are we describing for Y? What does that 8 represent? If we just look at this first row, what does 1 represent and what does 8 represent? And then lastly, is there a proportional relationship between X and Y? Can we find a constant of proportionality? Pause the video and try to find it. So our table is proportional because if I look at 1 in the X column and go to 8, what do I have to multiply 1 by to get 8? Well, I'd have to multiply 1 times 8 to equal 8. Well, let me double check that works through the rest of the table. 2 times 8 is 16. 3 times 8 is 24. 4 times 8 is 32. 5 times 8 is 40. And 6 times 8 is 48. So our constant of proportionality is 8. Okay, that means that for every t-shirt that I buy, I'm going to pay $8. So now, what if we plot these pairs on the coordinate plane or on my graph? So here's that same table, and then we have a graph here. So we're going to plot these as points. And we can just put parentheses around them to make it look like a coordinate. So it's already set up with X, comma, Y. In this case, 1, 8. So I'm going to start at the origin. That's what this fancy little O is. That's origin. And I'm going to go over 1, because remember X means left and right, and Y means up and down. So I'm going to go right 1 and up 8. But my graph is counting by 2s because I jumped from 0 to 10. And so I have to count each line as 2. So 2, 4, 6, 8. And I'm going to put a point and label it. You're going to plot the rest of the points in your book. So pause the video to do that and then come back to double check your answer. So I'm going to go over to 2 and I'm going to go up 16. Put the point, label it. Next point is 3 and then up to 24. So I'm going to go up to 20 and then 2 more lines is 24. Next is 4 and 32. Okay, 5 and 40 and 6 and 48. What do you notice about this graph? Is this a proportional graph? Does it meet our 2 criteria? Is it a straight line? And does it go through the origin? Yes, this graph is proportional. It is a straight line and it goes through the origin. So let's look at some other examples. Proportional or not proportional? That is the question. Look at these 3 graphs. Which one do you think is proportional? If you said this first one is proportional, remember your 2 characteristics. 1, it has to be a straight line. 2, does it go through the origin? Look at the X and Y axis here. That's the origin right here where they cross. Is that line going through that point? No. So this is not proportional. What about this graph? Is it a straight line? Well, right off the bat, we can say no because it has a curve or a bend to it. If it's not a straight line, it's not proportional. Go to the third one. 1, is it a straight line? And is it going through the origin? Yes. So this graph is proportional. Remember, the 2 characteristics for a proportional graph is that it has to make a straight line and it has to travel through the origin. Remember, the origin is 0, 0. You're going to go to your notes now, jot down anything that you might need to help you remember how to do this, how to determine if a graph is proportional or not proportional. And then I want you to draw one graph that represents a proportional relationship and one that does not. So for example 2, you're going to actually draw 2 different graphs, one that's proportional and the other one that's not. Have a great day.